Okay, so today we're going to talk about analyzing graphs of polynomial functions. So we've been talking about functions for a little while now. So now we're going to look at the two main things we always do with different functions: graph them and then solve them. So today we're going to focus on the graphing part. So some of the stuff is stuff we've done with graphs before, so some of it will seem familiar. Some of it's actually pulling in stuff that we talked about in the last section, and then some of it is new. So first I'm going to talk about what we're going to do with each one of our equations that we're going to graph. So for each graph, you're going to first graph it, and we're going to use our online graphing calculator. That's the Desmos graphing calculator that we've used in the past. So it's still going to be the same graphing program, and I'll show you how I got that graph in a second. As always, if you go to Classroom, if you go to the Classwork tab, I have it linked up here at the top. It's the online graphing calculator. Click that link, it'll go right to the decimals that we need. So again, we're still using that same graphing calculator program that we've used in the past. So there's that. You're going to snip it as well. So somehow you're going to use your snipping tool. Like on my computer, I have this particular snipping tool where I can click and drag and snip that way. Or you can use your specific print screen button on your Chromebook, which is Control, Shift, and then the print screen button that's up on the top row of your buttons. So again, you're going to graph it and then snip it, which will, again, we've done in the past, so hopefully you remember how to do that. Then we're going to do the y-intercept, which we've talked about y-intercepts in the past, so this is nothing new. It's where it crosses the y-axis, and all of our graphs should have one y-intercept. So for the second part, you're going to just state whatever the y-intercept is. You can do it as the whole ordered pair, which is like 0, 5, or you can just list the y value. Either way is fine. It's also always the last number in the equation, just like it was with when we were graphing just quadratics. So that's another helpful hint for the y-intercept. And the zeros, again, are the same type of thing when we're graphing quadratics. It's how many times the graph touches or crosses the x-axis. And so there could be several different numbers of zeros. With the ones we're working with, the biggest graph I think we will look at is a quintic. And actually the degree of the polynomial actually can determine how many zeros you have, and we'll talk about that here in a little bit. So we could have up to 5 zeros on one graph. So it's wherever the graph crosses or touches the x-axis. Again, not the y-axis, that's a separate thing, but the zeros are the x-intercepts. Extrema, and I have stars around this because this is new. This is something that we haven't really discussed fully. The extrema of the graph, or where the graph turns and changes direction. So wherever that graph turns, it creates a certain shape. And there's actually 4 different types of extrema that we'll talk about in a little bit. And then finally, this is something that we're pulling in from the last section. So it's state the degree and type of the polynomial. So just like we have been doing in the last couple days, degree is your highest exponent, and then the type of function is one of those words that we use to describe it. So it could be constant, linear, quadratic, cubic, quartic, and quintic. So one of those 6 types of functions. Like I said, when we do graphs, we typically don't go above quintic, because again, those are the ones that don't have a specific word. They're 6-degree polynomial, 7-degree polynomial, and so on. So again, when we focus, we mostly focus on degrees 0 through 5. So those are the different things we're going to do for each graph. So graph and snip, y-intercept, zeros, which are from pulling in from previous sections, extrema, which is a little new, and then degree and type we're going to pull in from the very last section. So those are the things we're going to talk about. So before we do some examples, we're going to talk a little bit more specifically about some of those things, just some reminders. So first of all, this just gives you kind of a general idea of what each graph could potentially look like. Again, they don't necessarily have to look like these. And then up here at the top, I'm going to narrow down the screen for a second. The degree of the polynomial is actually the maximum number of zeros that you can have. So like I said, if you have something that's degree 5, it potentially could have 5 different zeros. Now that doesn't mean that every single degree 5 polynomial has 5 zeros, because again, just different how it's shaped, will determine how many zeros it does have. Sometimes it might just have one, but again, it has that potential of having the maximum number of the degree. So that's one thing to watch out for. So these first three, like I said, we've talked about those in the past. We don't do a ton with constant functions. Those are degree zeros. Those are horizontal lines. They're kind of, there's not a lot happening with those, so we generally don't work with those a ton. Linear functions, we did a lot of lines in Algebra 1. Those are degree ones. So we don't see those a lot here either. We mostly focus on some of the new ones, but that is a potential of something we could graph. Quadratics, we did a whole unit on those, so that graph should look somewhat familiar. So that is degree 2, but again, it follows more of the trend of the different polynomials that we haven't talked about yet. We'll uncover the 3 new ones. So we have a cubic function, which is degree 3. It typically has 2 different terms in it. So the quadratic function typically just has 1 term. The more degrees you add, the more turns you have potential. So this one has 2 turns potential, and again, it possibly could hit the graph on the x-axis 3 different times. Like this one, degree 0 doesn't hit at all. Degree 1 hit it once. Degree 2 hit it twice. Quartic functions is degree 4. Again, it potentially could hit it 4 times. That means it would turn 3 separate times. Kind of looks like a W shape. Again, they don't have to necessarily look at this, because depending on the other terms you have in your polynomial, it could shape it. Sometimes quartic functions actually kind of look like quadratic functions, so that's why you have to get degree and type, you still have to look at the equation. And then a quintic function, degree 5, again, potentially it could hit 5 separate times along the x-axis, so it has several different terms. It has 4. So that's a little bit of a general idea of what graphs could look like. Like I said, sometimes quintics and cubics look very similar. So there's maybe not as much of a turn. So like if the slope here in the middle, they only turn once. Could also potentially not turn at all. Just kind of snakes up through. So we're going to look at several different types of functions as we go throughout. So now we're going to talk about those new words, the extrema. So I kind of mentioned the turning points of the graph when I was talking about on the last slide. So wherever the graph turns, it creates something called an extrema. So that's just a change in the graph. So your graph could be increasing and then stops increasing, it turns and starts decreasing, or it goes up and then it turns and goes down. That creates an extrema, or down to up. So whenever the graph turns, it creates a type of extrema. And so what we call those are minimums and maximums. Now we've used that word in the past. The minimum typically meant that it was the lowest part of the graph it could potentially go, and the maximum meant it was the highest the graph would go. But now we're throwing in some different types of minimums and maximums. So it may not be the exact lowest or the exact highest the graph goes, but it does create that shape. So typically maximums are created when your graph is going up and it turns and starts going back down. I always call that like a mountain shape. And the minimums were valley shaped because it happens when the graph's going down and then it turns and starts going back up. So those are our 2 general types of extrema. So now then to get them in more specifically, if it is not the lowest the graph ever goes, but it creates that minimum shape, that's called a relative minimum. Because again, the graph would be going down, it turns and starts going back up, but then eventually that graph will go lower than that initial turning point. So it's just the lowest point over an interval of the graph, not the entire graph. It's considered relative minimum. So we use that word when it's something that's not the lowest the graph goes, but it does make that turning point of a minimum. So then we also have a relative maximum, and that same idea, the graph's going up, it turns and starts going back down, so it creates a maximum shape, but then later in the graph, or earlier in the graph, it was higher than that point, so it has that maximum shape, but it is not the highest the graph goes, so we call that a relative maximum. So then what happens if they are the lowest or highest the graph goes? Those are the other 2 types of extrema. If it is absolutely the lowest the graph will go, we call that an absolute minimum. So that is the lowest the graph ever goes. There's no parts of the graph that are lower than it. So, sorry, I had to pause the video for a little bit, so I might repeat myself. So again, if the graph is the lowest the graph will ever go, that is called an absolute minimum. And so then the fourth type is, no surprise, it's an absolute maximum. So if it is the highest the graph ever goes, it's considered absolute. So that's the absolute highest the graph goes. There's no parts of the graph that are higher. Then that's an absolute maximum. So again, if it has that maximum shape but is not the highest it goes, it's relative. If it has that maximum shape and it is the highest graph goes, it is considered relative. Same thing for minimums. If it has that minimum shape and it's not the lowest the graph ever goes, it's relative. If it has that minimum shape but it is the lowest the graph goes, it's considered absolute. And then this last thing is we can actually have multiple types of each extrema of the graph. So again, you can have two relative minimums, two relative maximums. You can actually have two things that are absolute. So if they're on the same level, they're both considered absolute minimums. So again, it is possible to have multiple of each type. Typically though, if you have an absolute minimum, your graph also won't have an absolute maximum. So usually it's one or the other. And like I said, you could potentially have a graph that has two absolute minimums or two absolute maximums. We typically don't see these paired together. And then last, like I said, there is possibility to have multiple relatives. That's a very very high possibility for our graphs. So on the next slide is having some examples of what the relative minimums and maximums could look like. So I'll show both of these. So typically, this is a fairly typical graph that we have. So right here where this graph is going down and then hits a point and then turns and goes back up, that's considered a minimum. But there is a part of the graph that is lower than it, so it's a relative minimum. So typically what we do is we give its classification relative minimum, and then we list an ordered pair. So I just kind of made up a point here because these graphs really aren't labeled. So in our on our actual problems, we'll give an ordered pair a point for that spot where it turns and goes back up. So that's a relative maximum, and then the graph is going up, and then hits this point, and then turns and goes back down. So this is a maximum shape, but again, it's not the highest graph goes, because you can see this arrow is pointing up. So this before this point even happened, there's other parts of the graph that are higher than it, so it's also considered a relative maximum. So in this graph over here, we have multiple minimums and maximums. So again, the graph's going down, starts going back up. It's a relative minimum because again, there's other parts of the graph that are lower than it, so that's relative minimum. Then the graph is going up again and then hits this point, turns and goes back down. That's a relative maximum because again, this graph doesn't have arrows, but we always assume that they're going off in the distance forever. So this part of the graph is higher than it, so that's a relative maximum. And the graph keeps going down for a little while, and it hits this point and turns and goes back up. This is a minimum, but this one is considered absolute, because if you look at the rest of the graph, there's no other parts of the graph that are lower than that. So that is considered an absolute minimum. And the graph goes up for a little bit, and then it hits this point and turns and goes back down. It's another maximum shape, but again, there's other parts of the graph that are higher than it, so it's relative. And then the graph turns one more time down here, so there's another relative minimum. So then we considered this one relative, again, because there's other parts of the graph that are lower than it. So this graph has two relative minimums, two relative maximums, and an absolute minimum. So this one has several different extrema, so you can list all of the ones that are possible. So every time the graph turns, it creates an extrema, so we list the type, and then we also list the ordered pair with it. But this graph here is a little bit different. So it's going up for a while, then it hits this point, turns and goes back down. That's a maximum, and it is the highest graph goes, so it does have an absolute maximum. Then it turns and goes down for a little bit, hits this point, turns and goes back up, so we have a relative minimum, but again, there's no absolute minimum, because there's no parts of the graph there are parts of the graph that are lower than this one. And it goes up for a little bit, hits this point, and then turns and goes back down. But there's other parts of the graph that are higher than it, so it is a relative maximum. So this one just has 3. But like I said, typically if there's something that's an absolute minimum, then your graph won't have an absolute maximum, because most of the time the other ends, the arrows, are pointing the opposite direction up forever, so there is no absolute maximum. With this one, there's an absolute maximum, but the arrows are pointing down forever, so there is no absolute minimum. I'm actually going to flip back real quick before we go to the examples. because I like this graph, because I just did say that there is a possibility that you have two absolutes of something. So like if we look at this graph that I had for the quartic function, this graph has two absolute minimums. So that we list both of those. We list whatever point we'd say. If we make up numbers, that would be like -2, -5, and then +2, -5. So both of those are considered absolute because those are both the lowest the graph goes. They're both minimums. So you can have a graph, and a lot of times it looks like this, where there's two absolutes possible. So like this one just has a relative and a relative. This one has a absolute, two absolute minimums and a relative maximum. And then this one, all of these are relative because again the arrows are going in opposite directions. This one has an absolute max. So again, I just wanted to flip that to that graph real quick so you can see that potential. So now we're going to look at what our problems are going to look like for you. So like I said, we have all these parts. So a graph and snip, state the y-intercept, zeros are the x-intercepts of the graph, list and label extrema, again that's the new stuff we just talked about, and then the degree and type just like we did before. So this is where you're going to take this equation and you're going to go to Desmos and type it in, okay? So I didn't have to keep flipping back and forth. I do have them already pre-typed in, so I'm going to show that here in a second. But just a real quick of how you get exponents. Since we've done exponents before, just a reminder. So the way I typed in 4x to the fourth, you do 4x, and then I do the quick key shift and then the number 6. And then notice it puts my cursor up in the corner, so that will give me that exponent. If you don't like the quick keys, you can use the online keyboard. This little button will also give you an exponent. So if I do 5 equation, and then you can hit that key, and then that'll put that cursor. Again, I like quick keys, so I use shift and then number 6, and that'll put the cursor right there. I'm gonna go to my pre-done graph. The nice thing about Desmos is it does a really good job of pulling points that we need. So we need the y-intercept, which the y-intercept is where it crosses the y-axis. So we need this point, and again, if you click on that, it'll stay there. So a reason why I highlighted it is when I do my snip, I like to see the points on it. So again, I don't have to keep flipping back and forth screens. So I'm going to highlight my y-intercept. My zeros are where it crosses the x-axis. So I can click on those. There are 2 of those. Again, this one's degree 4, so it did have a potential of having 4 zeros, but this one just has 2, so those are 2 zeros. The degree and type I can't highlight because that comes from the equation. This is degree 4, so type would be quartics. I already know the last part. And then every time the graph turns, it creates an extrema. So what we can do is if you click and highlight, the one thing is you have to make sure you keep track of what each point is. So that way if you do highlight everything, you can keep track of it. So these 2 are zeros. This 0, -2 is my y-intercept. Then I have 3 different extrema. So now I'm going to snip that. So usually what I try to do to get a snip, get a good portion of the x and y axis. Which I'm going to find cursor so you can see it. That works. So you see a good portion of my x and y axis here. See all the points, see all the different curves. Sometimes with these you may have to zoom out a little bit. But then once you have the snip, I'll have a document on Google Classroom for you. So you're going to snip that in there. If you don't like how big it is, you can always resize it. I always resize it a little bit. And then we're going to do the rest of the parts. So I did the graph and snip. So now I'm going to do my y-intercept. So the y-intercept is that 0, -2. Again, you can tell it's a y-intercept because the first value is 0, and then the y value would be y-intercept. So if you just wanted to write -2, that's fine. But again, there's my y-intercept. It's also always the last number in the equation. So we still can use that. Then we do the zeros. So that's where the where it crosses the x-axis. So now you know it's a 0 because it's a number, comma 0. So we got -1.406, comma 0. Again, if you just want to list the x values, that's fine. But for this example, I'm going to list everything. So there's my zeros. That's where we get into the new stuff, okay? So we're going to list and label all the extremas. So every time the graph turns, which there's 3 different ones, there's this -1, 0 that goes with this point. So that's why I said you really have to make sure you keep track of what point goes where. So this point was at -1, -2. This point was at -0.0403, -1.338. 465 and -3.138. So, move back to my document. So this first one, I'm just going to go from left to right. The graph's going down, it turns and starts going back up. So that is a minimum, and it is not the lowest the graph ever goes, so that's considered a relative minimum. And then we type the point. So we have to keep both values with this one. So -1, -2. There's our first extrema. So then we also have this next one. The graph goes up, it turns and starts going back down. So again, since it's going up and turns and goes back down, that's a maximum. But there's other parts of the graph that are higher than it, so we have a relative maximum. This point, which again is the -0.403, -1. Relative maximum. I'm actually going to return that. And then we have one more turn because the graph doesn't go up forever for the rest of the time. It turns and goes back down, and then it hits this point, and then it turns and goes back up. So that's another minimum, but that is the lowest the graph will go. That is an absolute minimum. Then finally, part E. Now, like I said, part E doesn't actually come from the graph. It still comes from the equation. So the degree is still 4 and the type is still quartic. So whenever we do this, I do still like you to type degree 4. So make sure you list the number and type. Okay. So there is the first graph. So we have graph and snip, y-intercept of the graph, zeros, relative minimum, relative maximum, absolute minimum, because the graph turned 3 times, degree is 4, and the type is quartic. So all that came in from the folder. Alright, so let's do our next one real quick. Go ahead. And see. So, like I said, I pre-typed this so I don't have to keep flipping back and forth screens. There's my second graph. It is a quintic because it's degree 5. It has several different turns. So, again, if you click out here, the points go away. If you either click where you type, or if you specifically click on the green line, then the points will pop back up. So I have my y-intercept here. I'll highlight that. We have several zeros. There's 1, 2, 3, 4, 5. Ooh, I don't like that. So sometimes when you highlight them, they kind of get in the way of things. So I'm actually going to go back and highlight these first, then highlight my zeros. So, like I said, sometimes when you get this, since there's several points on this graph, it kind of gets in the way of each other, so you have to really make sure you're keeping track of where every point came from. And so if you really don't like the way that looks, you can just snip it like this. Doing something like that. Again, make sure you keep the X and Y axis in there, get a good portion of the graph, so that way you can see that it's going down forever and up forever, so you can notice that these are all going to be relative. So if you don't like the way that looks, where they're all on, all the points are on there, because sometimes they can get lost in all of that, you can do it where you don't highlight. You'll just have to flip back and forth a little bit. That's what I'm going to do in this example. So I've got my y-intercept. So again, it's the last number in the equation, -1, or if I flip back here, it's that point right there. So each example I'm going to do slightly different, so that way you can see some variations. So if you get something like it, as long as you have all the stuff listed, that's what I want. So now we're at zeros, which there are several. So this time I'm not going to list them as pairs, I'm just going to list them as x values. So I got -1.8, and you don't have to necessarily list all the digits either. So -1.8, -1.3, I'm going to type those. And I got 0.2. 1 and 1.95. So there's our zeros. Next thing is extrema. So this graph turns 1, 2, 3, 4 different times. So we're going to have 1, 2, 3, 4 different extrema. Now these, so this one's going up, it turns and starts going back down, so that is a relative maximum. So I'm going to say relative max for -1.6 on 1. The next one, it's going down and goes back up. This one's a relative minimum, because again, there's other parts of the graph that are higher than this, and actually none of these are going to be absolute, because this graph goes up forever, so there's always going to be parts that are higher than that, and there are always going to be parts that are lower than this, because it goes down forever. So this is the relative minimum as well. So I got -0.6 and -3. Then our graph goes up for a little while, and then it hits another point and turns. So this is another relative maximum. So you can either list it a second time, or you can start typing relative max down here, or since I've already labeled that one of them, I can actually just kind of make it as a list. Oh, I've forgotten what the point is. We have 0.6 and 1. But again, if you have two relative maximums, instead of having to write a relative maximum twice, you can just put both points behind it, so you can kind of create a little list. I'm going to do that same thing here, because there's another relative minimum here, because the graph goes down for a little while, turns and goes back up. So I got positive 1.6 and -3. And then finally, the last part is degree and type. Again, degree and type doesn't come from the equation, or it doesn't come from the graph, it comes from the equation. So the degree is 5. I do list both the degree and type in this list. So that would be what the assignment will look like. So each assignment has about 4 to 6 graphs depending on what it is. And again, these graphs, I tried to pick ones that had a lot going on with it. Some of our graphs can be very minimalistic. You'll always have a y-intercept. You can actually have a graph that doesn't have a 0. So it can, like if I had just taken this graph and shifted it up a little bit, it wouldn't hit the x-axis. So it is possible to have no zeros. It is actually possible to have no extrema. So real quick, I want to type an example of what that would potentially look like. So if I just, like this graph, if I just had this one, maybe add a little bit more to it. So this graph, it has a y-intercept and has a 0, but this graph does not definitively turn. So in order for it to have an extrema, you have to make sure you change direction. Let's see if I can make it do that. So like this one, if I just add the x in there, it definitively turns here and goes back down. So it creates an extrema. This one doesn't. So this one kind of flattens out here for a little bit and then keeps going up. So if that ever happens, it is possible to have no extrema. And it is also possible to have your extrema be like the same type of point. it's close enough. So sometimes your graph will have a minimum here, but it also might be a 0. This one's not quite there. If I just do 1, again, it's not quite there, but again, that is a possibility for your extrema to also be one of your one of your intercepts. So you could have a y-intercept that's also an extrema. So there's some points that can double up. Like I said, I tried to pick some graphs that were very interesting and had a lot of stuff going on. So some of it will not have quite as much. So again, you always have a y-intercept. The degree and type comes from the equation, doesn't come from the graph. So you'll always be able to find those two things. Like I said, zeros, sometimes you'll have 1, sometimes you'll have 5. So you could potentially have none. And then the extrema, a lot of times they give it to you where there's 2 or 3. But sometimes there's only 1, sometimes there's none. So it just varies. So that's what we're going to do the next few days, is work on several different graphs to get you exposed to all the different things we can do. So hopefully this all made sense. Let me know if you have any questions.